Connecting automatic transfer switches, or outages, to an emergency generator involves several key steps to ensure reliable backup power for essential systems. Firstly, mount the ATS. Install the ATS in appropriate locations for each system, such as the fire pump, fire alarm, and lighting exit signs in the elevator. Secondly, connect the service disconnect to the generator. Run cables from the service disconnect to the generator input terminals on each ATS. Thirdly, connect the load disconnect to the system. Run cables from the load disconnect on each ATS to the appropriate electrical panels for each system, for example, fire pump, fire alarm, lighting, exit signs, and elevator. Fourthly, connect the generator to the ATS. Run cables from the generator output terminals to each ATS. Fifthly, configure the ATS settings. Program each ATS to automatically transfer power from the normal grid feed to the emergency generator upon a power outage. Turning to the fuel tank connection for the emergency generator, follow these steps to ensure a reliable fuel supply. Firstly, install the fuel tank. Place the fuel tank in a designated area near the generator. Secondly, connect the fuel tank to the generator. Run a fuel line from the fuel tank to the generator's fuel inlet. Thirdly, install a fuel filter. Install a fuel filter between the fuel tank and the generator to prevent contaminants from entering the engine. Fourthly, prime the fuel system. Using a priming pump or hand pumping, fill the fuel line with diesel fuel to remove any air pockets. Fifthly, start the generator. Start the generator and allow it to run for a few minutes to check for leaks or any other issues. To elaborate on connecting the ATS, it is crucial to use appropriately sized conductors based on the amperage rating of the connected loads and the generator's capacity. Consult the National Electrical Code, specifically Article 710, for emergency systems wiring requirements. Ensure that all wiring is performed by qualified electricians and complies with local codes. Consider using flexible metal conduit or liquid-tight flexible metal conduit for connections to allow for vibration and movement. Label all cables clearly to avoid confusion during maintenance. When mounting the ATS, consider environmental factors like temperature and humidity. The ATS should be housed in an NEMA-rated enclosure suitable for the location, such as NEMA 3. R for outdoor use or NEMA 1 for indoor, dry locations. Proper grounding is essential. Ground each ATS according to NEC 250. 4. A5 to ensure safety and proper operation. The grounding electrode conductor should be sized per NEC table 250. 66. Based on the size of the service entrance conductors. When connecting the service disconnect to the generator, use a properly sized circuit breaker or fuse disconnect switch at the service entrance to protect the generator and ATS from overcurrent. Ensure that the voltage and phase configuration of the generator matches the existing electrical system. For example, if the building uses a 208/120 volts, three-phase system, the generator should be configured to provide the same output. The generator neutral should be properly bonded to ground at the generator location as per NEC 250. 30. When connecting the load disconnect to the system, verify that the electrical panels for each system are properly labeled and that the connections are made to the correct breakers. Use appropriately sized conductors and conduit to handle the load current. Consider using surge protection devices at the electrical panels to protect sensitive equipment from voltage spikes. When connecting the generator to the ATS, use flexible connections to minimize vibration transmission. Ensure the generator output breaker is properly sized to protect the generator from overload. Install a generator exercise timer to automatically run the generator periodically, such as weekly or monthly, to ensure it is in good working condition. Refer to NEC 700. 8. Regarding testing and maintenance requirements for emergency systems. When configuring ATS settings, set the transfer time delay to an appropriate value to prevent nuisance tripping. Adjust the voltage and frequency sensing settings to match the generator's output characteristics. Program the ATS to automatically transfer back to normal power when utility power is restored and stable for a predetermined period. Regarding the fuel tank connection, it is essential to select a fuel tank that meets local fire codes and environmental regulations. The fuel tank should be constructed of materials suitable for storing diesel fuel, such as UL 142 listed steel tanks. The tank should be equipped with a vent to prevent pressure buildup and an overfill prevention device to prevent spills. The fuel line should be made of fuel-resistant material, such as reinforced rubber or steel tubing, and should be properly supported to prevent sagging or damage. When installing the fuel filter, choose a filter with the appropriate micron rating to remove particulate matter and water from the fuel. Regularly inspect and replace the fuel filter as needed to maintain fuel quality. Priming the fuel system is crucial to remove air pockets that can prevent the generator from starting. Use a hand-operated priming pump or an electric fuel pump to fill the fuel lines and filter with fuel. Open the air bleed valve on the fuel filter to allow air to escape while priming. Once fuel flows steadily from the bleed valve, close the valve and continue priming until the fuel lines are full. When starting the generator, follow the manufacturer's instructions for starting and operating procedures. Monitor the generator's voltage, frequency, and oil pressure to ensure it is operating within normal parameters. Check for fuel leaks and exhaust leaks and address any issues promptly. Regularly inspect the fuel tank for leaks, corrosion, and damage. Keep the area around the generator and fuel tank clear of combustible materials. Install a remote monitoring system to track the generator's performance and receive alerts in case of a problem. Maintain a log of generator run times, maintenance activities, and any repairs performed. Train personnel on the proper operation and maintenance of the emergency generator system. Conduct regular load bank testing to verify the generator's capacity and ensure it can handle the connected loads. Update the emergency power system drawings and documentation to reflect any changes or modifications made to the system. Always follow safety precautions when working with electrical equipment and fuel systems. Wear appropriate personal protective equipment such as gloves, safety glasses, and hearing protection. To energize circuits before working on electrical connections. Use proper lockout-tagout procedures to prevent accidental energization. Work in a well-ventilated area when handling fuel. Avoid smoking or open flames near the fuel tank or generator. Dispose of used fuel filters and other waste materials properly. Keep a fire extinguisher readily available near the generator and fuel tank. Familiarize yourself with the emergency shutdown procedures for the generator in case of a fire or other emergency. Consult with qualified professionals such as electrical engineers and fire protection specialists to ensure that the emergency power system meets all applicable codes and standards. Obtain all necessary permits and inspections before installing and operating the emergency generator system. Ensure that the emergency generator system is properly maintained and tested regularly to ensure its reliability in case of a power outage. Consider the long-term maintenance requirements and costs when selecting an emergency generator system. Budget for regular maintenance, fuel costs, and potential repairs. Invest in a high-quality emergency generator system from a reputable manufacturer to ensure reliability and longevity. Obtain multiple quotes and compare features and specifications before making a purchase. Evaluate the generator's fuel efficiency to minimize operating costs. Consider the noise level of the generator and select a model that meets local noise ordinances. Ensure that the generator is properly sized to handle the connected loads. Oversizing the generator can lead to inefficient operation and increased fuel consumption. Undersizing the generator can result in overloading and potential damage to the generator and connected equipment. Perform a load analysis to accurately determine the power requirements of the essential systems. Consider future expansion plans when sizing the generator. Select a generator with sufficient capacity to accommodate future load growth. Consider the availability of fuel and the reliability of the fuel supply. Choose a location for the fuel tank that is easily accessible for refueling. Consider installing a fuel level monitoring system to track fuel consumption and prevent running out of fuel. Ensure that the fuel tank is properly protected from vandalism and theft. Consider the environmental impact of the emergency generator system. Select a generator that meets emission standards and minimizes air pollution. Use environmentally friendly fuel additives to reduce emissions. Implement energy-efficient measures to reduce the overall power demand of the facility, thereby reducing the size and fuel consumption of the emergency generator. Consider using renewable energy sources, such as solar panels or wind turbines, to supplement the emergency power system. Explore available incentives and rebates for installing energy-efficient and renewable energy technologies. Educate occupants of the building on the importance of energy conservation and emergency preparedness. Conduct regular emergency drills to familiarize occupants with the emergency procedures. Post emergency contact information and procedures in prominent locations throughout the building. Maintain a comprehensive emergency plan that outlines the steps to be taken in case of a power outage or other emergency. Review and update the emergency plan regularly to ensure it remains effective. Coordinate with local emergency responders and utility companies to ensure a coordinated response in case of a major power outage. Participate in community emergency preparedness exercises to improve coordination and communication. Stay informed about potential threats and hazards that could affect the facility. Monitor weather forecasts and emergency alerts to anticipate potential power outages. Take proactive measures to mitigate risks and protect the facility and its occupant. Ensure that all emergency lighting and exit signs are properly maintained and tested regularly. Provide backup power for critical communication systems, such as telephones and radios. Maintain a supply of emergency supplies, such as flashlights, batteries, and first aid kits. Consider the needs of individuals with disabilities when developing emergency plans and procedures. Provide accessible communication and evacuation routes for individuals with mobility impairments. Train staff on how to assist individuals with disabilities during an emergency. Ensure that emergency power systems are designed and installed in accordance with all applicable codes and standards to ensure the safety and reliability of the system.